So let's continue our uh, theoretical part of model, and the last part is urban and water indices. So besides vegetation indices, which are widely applied in remote sensing, there are plenty of other types of indices which are used to detect other types of land classes such as urban and water. So let's go back again to the spectral signature. So we can see here that to detect water and urban land classes, we can see here different land bands can be applied. So it's urban material, right? So we can see here the urban reflects very small part of energy in the visible spectrum, and the reflectance of energy in near infrared and thermal infrared significantly rises comparing to visible spectrum, while the water mostly reflects very small energy on visible spectrum here, and almost no energy in the near infrared and shortwave infrared as well. Therefore, we can compare the reflectance in the shortwave infrared and near infrared with visible spectrum in order to detect water, and we can compare the reflectance of near infrared and shortwave infrared with the reflectance, for instance, in green color spectrum, right? This one, in order to detect urban areas. So urban indices. There are lots of indexes for the analysis of built-up area. Examples are normalized difference built-up index and NDBI built-up index, urban index, index-based built-up index, IBI, enhanced built-up and bareness index. So this is a map of with satellite image after application of NDBI, normalized difference built-up index. So we can see here on red, with colors with the red and the orange areas have a high percentage of built-up pixels, while pixels areas with green color have a very low percentage of built-up index. These can be considered as the natural areas, grasslands, forests, or bare soil, etc. While these red and orange areas have more a lot of urban entities. So the formula of NDBI is here: short wave infrared minus near infrared, and short-wave infrared plus near infrared. So we can see here from the spectral signature, so this area is can be considered as short-wave infrared, right? Very high percentage of reflectance, and these areas are considered as near infrared. So as bigger the short-wave infrared, and the bigger the ratio between short-wave infrared and near infrared, the higher the percentage of built-up area. So mostly we will use this index, normalized difference built-up index, which is the most popular. But you can also test other indexes. You can find the formula of, for instance, other indexes such as built-up index, urban index, and other indexes in the internet. So also water indexes, which we will apply. Normalized difference water index for leaves. There are two types of normalized difference water index. NDWI is a satellite derived index from the near infrared and short wave infrared channels. The three reflectance reflects changes in both the vegetation water content and the spongy mesophyll structure in vegetation canopies, while the near reflectance is affected by leaf internal structure and leaf dry matter content but not water content. So normalized difference water index for water bodies. For this index is used to detect water bodies. It's very simple. Green means near, green plus near. So water mostly reflects the blue and the green colors, and almost no reflectance in near infrared spectrum. So the values which are less than 0.3 are non-water, and the values which are higher than 0.5 is almost considered as water areas. So this is the image or the final map of a satellite image after application of NDWI to detect water bodies. So this formula, right? So we can see here is a very precise detection of water areas which are colored with blue. And also there are other types of indices used for water. So it's a modified NDWI and water ratio index. So you can see here the formula of water ratio index: green plus red, and divided into near plus short wave infrared 1. So these indices we will apply during the tutorial video. So let's start our tutorial, but before that we should download a satellite image from the internet, and on the following video I will show you how you can download satellite image for your study area. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.